Hello, I'm Reggie York. This is a presentation on using the special Excel file for the independent t-test. That is the file that I have created where you only have to put in your data in Excel and get the results of your use of the independent t-test. I'm going to stop here and let you read this. You will pause the screen and read the instructions there. So as you can see, I'll be illustrating how to compare the gain scores of two groups. The independent t-test can be used for comparing data for two groups when you have interval data. That will be the case with regard to computing the gain score of two groups, a treatment group and a comparison group. What you need to make use of this is the special Excel file that I have designed that accompanies this particular book I have written. You need to have your own data, a set of scores for group 1, a set of scores for group 2. I'm going to illustrate using some hypothetical data myself. An example for illustration, here we have the gain scores for group 1, let's call this the treatment group, are 15, 17, 15, 14, 19, 21, 23, 20, and 17. This means you've computed the pretest score and post-test scores for each person, and this is how much the difference was. This is how much there was a gain. There are no negative numbers here. You could have a negative number, however, if somebody had gone down. That is not the case in this particular illustration, but that is a possibility. The gain scores for group 2, the comparison group, are 3, 5, 3, 4, 7, and 3. So we have 6 people in the comparison group, and we have 8 people in the treatment group. Here is the hypothesis we will be illustrating. Gain scores for the treatment group will be higher than the gain scores for the comparison group. And that's what the independent t-test will help us to test. This is what we will get after we enter our data. We'll get a mean gain score for group 1, a mean gain score for group 2 to see if there's a difference, see if the treatment group had a better gain score. That's your first step in testing your hypothesis, decide whether the data goes in the hypothesized direction. You get the value of t, and the value of p to determine statistical significance. Also, effect size will be reported. That is something that can help you with regard to practical significance. Now let's look at the Excel file. Okay, here we go. This is the special file I put together. If you want to pause this for a moment and read the instructions, you can be happy to do that before I start talking. Okay. Basically what you do here is you put treatment scores right here. We will enter these scores for the treatment group. These are gain scores, by the way. The independent t-test can be used for comparing two groups on the basis of an interval variable. Gain score is an interval variable. So let's start with the treatment group. We have a score of 15 for the first person in the treatment group, a score of 17 for the second person, a score of 14 for the next person, 19, then 21, then 23, then 17. Those are your scores for the treatment group. Here's the comparison group scores: 3, 5, 3, 4, 7, and 3. 3, 5, 3, 4, 7, 3. You can see, of course, that the comparison group had a much smaller set of gain scores. You can look over here just to see what the mean was. The mean for the treatment group is shown here. 18 is the mean gain score for the treatment group. The mean gain score for the comparison group is only 4.1667. Obviously, the treatment group had a better mean gain score. Question becomes, is this a statistically significant difference in scores? Here is the value of t, which is used for determining the value of p, and you use the report to t. Here's a situation where I'm glad this happened because it gives me an indication of how to tell you something about a funny thing in regard to Excel. If the decimal points of the particular thing that is calculated is greater than just a few decimal points, it goes further than what they have, it'll give you this weird little thing, E-07. E-07 simply means move this decimal place 7 points to the left. That means that you'll have 6 zeros in front of the 5, because that would give you 7 places to the left. So this would be 0, 0, 0, 0, 0, 0, 5, 9, 5. So that's what this says. This does not mean that the p-value is 5.95, not even close. It's 0.00, so forth. So obviously this is very statistically significant, much lower than 0.05, the normal standard for social science data. Okay, here is the effect size, 9.45. That's quite high, as you might imagine, because this difference up here between these two groups was quite big. Well, this is an indicator of it right here. So here is your effect size, determine practical significance, whether this difference is really meaningful or not. Here is your p-value, determining whether statistical significance was achieved. Here is your two mean values showing unequivocally that the treatment group did better. Okay, I hope this helps. Here is information in case you forgot what I just told you. If you get a designation, this particular illustration is E-04, we had E-07, but anyway, if you have E-04, and this, you'd be moving your decimal place 4 points over. So if you got 1.23 E-04, move this 4 points over. 1, 2, 3, 4. So you have 3 zeros and a 1 before your decimal place be over there, 0.000123. And here's how it would look. Okay, good luck.